And I know these are kind of tedious. I took some hard ones, some tedious ones, just so I can practice the difficult ones. Okay, so this is our function here, polynomial function. First step, y-intercept. Plug in the 0, we're left with 3. Okay, 0, comma 3. So it's right there. Next one, end behavior. We know this guy is x to the 4th, so that means it's going to be similar to x squared, even. So that means it's going to be going both up. So the both ends are going to be going up. Okay. Next, how many turns, how many bumps is going to have? Well, it has 4, degree of 4. That means it's going to have 3 bumps, 3 hills. And you probably already know by now, but anything to the 4th power is going to look like a W. So it's going to look something like, something like a W. So we got our y-intercept, our end behavior, we know it. Okay, it's positive x squared, similar to the x to the 4th, and they're both going up. Why? Because it's positive. If there was a negative here in the front, then they would be going down. The end behavior would be facing down. Okay, we know that the turns, the bumps, x to the 4th, there's 3 bumps. Next, all right, we want to go ahead and factor. All right, so we set the y equal to 0 to find the x-intercepts. And we have this guy here. Well, I can't factor that guy. Normally with 4 terms, you should try to use a factor by grouping. But if you do that, you're going to find that it doesn't work. So we have to use the rational roots theorem again. Remember, this is your P. This is, guys, your Q. So factors of 3, 1, and 3, plus or minus. And then factors of this guy is 1. So 1 divided by 1. And 3 divided by 1. So the possible zeros are 1 and 3. So there's 4 possibilities. And what do? Well, I do synthetic division. So here's x to the 4th, that's 1, x cubed, that's 1, x squared, negative 3. There's no x, so I have to put 0, and then there's a constant of 3. So what do? I start using this guy. Let's try 1. Bring it down, multiply. 1 and 1 gives me 2. 1 times 2 is 2. Negative 3 and 2 give me negative 1. 1 times negative 1 is negative 1. 0 and negative 1 is negative 1. 1 times negative 1 is negative 1. 3 minus 1 is 2. That doesn't work. Alright, so then we try negative 1. And I did that over here. Same thing. I did the whole process. Bring down the 1. Multiply it. Gives you negative 1. 1 minus 1 is 0. Multiply it. Gives me 0. Negative 3 and 0 is negative 3. Multiply it. Positive 3. And you end up with 0. What does that mean? X equals negative 1 is a factor. That's great. I can use that. So when I do that, now this guy here, instead of being x to the 4th, is x to the 3rd. There's no x squared. Minus 3x plus 3. Alright, I gotta try to keep going. Man, I wish this was a quadratic, that way I can factor it, but it's not. It's a cubic again, and I really can't factor this. So what do? Rational roots theorem again. I know, kind of tedious. Same thing. P over Q, factors of 3, 3 and 1. Factors of x cubed, 1. So my possible zeros are the same thing, plus or minus 1, plus or minus 3. So now we do synthetic division just with this guy right here. Okay, and I went ahead and I did it down here. Okay, so now we're gonna have 1 for the x cubed. We're gonna have 0 for the x squared. Okay, so 1 for the x cubed, 0 for the x squared, negative 3 for the x, and positive 3. And as you can see, I tried positive 1, didn't work. Negative 1, didn't work. I tried positive 3, didn't work. I tried negative 3, didn't work. I couldn't factor this guy. Why? Well, because it's going to end up being a decimal. So the only one real x-intercept that I was able to get is this guy right here at x equals negative 1. Okay, so the last thing I'm going to do just to figure out where this guy kind of crosses is my rule of signs. So I start off here. So remember, we start off with the regular function. So from here I go, okay, this guy's positive, positive, positive to negative, that's one sign change. Negative to positive, that's two. So that means I have two sign changes. Great, that means there's two positive real roots. Okay, that means it's going to cross here twice. Now what about this guy? Plug in the negative x, negative x, negative x. This is even, so it becomes positive. This is odd, so it stays negative. This is even, but because with that negative on the outside, it becomes negative 3x squared. And then we have the 3. So let's go ahead and see how it changes. Positive to negative, that's 1. And then this guy, no change. And then negative to positive, that's another one. So there's two sign changes on the negative side. So there's two negative real roots over here. So there's two positive and there's two negative. Lastly, what I did, I just kind of picked some points. I just kind of want to give myself a reference point. So I just picked -2. Just something very simple, not complex. And then I plugged it in. I got 16 minus 8. And minus 12 plus 3, f of -2 equals -1, somewhere here. So it looks like this guy looks like, let's see here, I don't know, crosses here somewhere, it has to go back up and then comes back down. Now remember, over here there's no how should we say, there's no whole integer root, so it just crosses here and then at some point has to come back up. Okay, so something like so. Now if you want to get real detailed, you go ahead and pick points just to be more precise. But if your professor, your teacher is looking for a quick sketch, understanding end behavior, the Descartes rule of signs, this should be perfectly fine. If you notice the end behavior is correct, we got 1, 2, 3 bumps. You got 2 negative